So without further ado, we're going to go to the first panel. So we have Ali from Protocol Labs online. Hi, Ali.
Hi, Carlos. How you going? And 100%, I love hackathons. It's all about innovating and trying new things. So that was, yeah, a really good message there.
Definitely. So is it good evening for you, or?
Yeah, it's I'm in Australia. In case you couldn't tell from the accent, but yeah, so it's 10 o'clock here, 10 p.m. But good morning to everyone over in Europe, or I don't know what time it is in America. Probably super late there. I don't know.
I think they're still asleep. I think they're still asleep there.
Yeah, they might be. Yeah, a bit of crossover here though, which is cool.
Yeah, I was saying on the start of the session yesterday, we have people from 46 nationalities crossing 16 time zones. So some people are definitely asleep. Others are kind of midway through the afternoon. Others, like me, are just starting the day. And some others like you. There are some people from Australia participating in the hackathon as well. So some are kind of in their kind of early evening or late evening. So I think this is going to be fun. Ali, the stage is yours. I'm looking forward to your session.
I will just, I don't think I can share the screen, Carlos.
I've just stopped my sharing. You should be able to share now.
Actually got a disabled participant screen sharing message. Might need to enable it for me.
Just a second. Oh, done. You should be able to go now.
Amazing. Thank you so much.
Welcome.
Alrighty. Cool. G'day, good morning, afternoon, evening, everyone. Thanks for tuning in today from wherever you are. And let me know in the chat. I'd love to hear where you're from. This kind of one of those really unique things about, virtual hackathons that we can tune in and participate from everywhere. So it's cool getting to know so many different nationalities as well. So I'm super excited to be here today, and shout out to Faber, Carlos, and all the organizers for running this awesome event to participate and build at. Like I kind of said, I love hackathons because they're really an amazing way to harness the power of community and innovation. And they really kind of capture the spirit of why I got into tech in the first place, which is the impact that innovation and innovative science and tech can really have. There's like a huge capability for tech to help transform our lives and the way our society functions. We can see that just by, how we survived over COVID if we weren't able to communicate like via Zoom and by digital tech. So it can really create new industries and collaboration paths and really help us solve complex problems. So anyway, that's a long-winded way of saying really looking forward to seeing the projects and ideas that come out of this. Also joined here today by Biscuit. He's our Filecoin corgi. I've just named him Biscuit too. He's a good doggo and he'll be helping me with my demo today. So say hi to Biscuit. So I'm Ali, Australian, as I said, developer advocate here at Filecoin, which means I get to work on my passion, which is helping enable others to build out their ideas and supporting developers on their own journey. And I'm really part of this big open source Web3 project, which I kind of coin as the ultimate open source project in blockchain and the wider tech community. So I've got a mechatronics and computer science background. I'm a developer. I used to own a cafe as well. But yeah, my passion is in developer advocacy these days. So that's a little bit about me. If you want to know more, feel free to hit me up as well. So what's on the agenda today? Firstly, I am going to show you how to make a NFT, how to code one up and make a front end and connect to that front end and deploy it today. And I'm going to show you why IPFS and Filecoin are important in NFTs. And if you didn't catch the session by my colleague Konstantin yesterday on, kind of some of the use cases of NFTs, don't worry, I'm going to go through a little bit of background on them first. And before you tune out as well, they're not all just hype, just in case, because I know there's a lot of noise around NFTs at the moment, so we want to break that down. But really, I want to be a little bit more hands-on. So I'm going to do that by showing you how you can create an NFT contract in Solidity. use IPFS and Filecoin dev tool project called Nft Storage to ensure we store the NFT metadata securely and persistently and immutably. And I'm also going to show you how to deploy, say you've written a front-end dApp. I'm going to show you how to deploy that on Fleek, which is a hosting site pretty much like Netlify or Vercel, but it's kind of cooler because you are deploying it with IPFS under the hood. So it gives you this hash for the content, and you can ensure that it's the same content every time, unless of course you change the Git, which, you know, that's exactly what you want to do with a hosting site. Anyway, I'm going to show you, you know, hands-on how to do a couple of those things. So let's talk about NFTs. NFTs have become a really big story in the last year or so. So with celebrities and big brands everywhere releasing their own NFT collections, millions of dollars changing hands for them. Auction houses like Sotheby's getting involved in auctioneering them. Tweets and code have been sold as NFTs, and even the Australian Open tennis tournament, which was held here in Melbourne recently, released NFTs, allowing people to own a piece of the action on the courts. So there's really a lot of noise and hype going on in the NFT space. And when you start your NFT journey, it can be a little overwhelming to look past some of this noise and to try and get a clear understanding of what the inherent nature of a non-fungible token, NFT, is. Because they're not just collectible digital assets, but they can have a lot of utility outside this, and they have the potential to really disrupt some industries or to enhance others. As we've already started to see with some artist markets that you might be aware of. So, you know, we've all heard the stories about how Spotify and YouTube aren't really paying their creators. And this is kind of spawning new industries with NFTs to give like kind of artists control of their own work back. First, so what's an NFT? A non-fungible token. Is it, you know, if non-fungible? When I first saw that, I just went, is this part of the mushroom family? Okay, not really. Obviously not. But a non-fungible asset simply means that it's unique. It has a limited number associated with it. So unlike other assets, like, for example, Bitcoin or money, where you can trade one Bitcoin or euro for another Bitcoin or euro and you have the exact same thing, NFTs are all one-of-a-kind assets. So the analogy is more akin to trying to swap the Mona Lisa for Girl with a Pearl Earring. They're not equivalent. So this non-fungibility and their basis on blockchain gives NFT some essential properties. And I know my colleague, like I mentioned before, Constantine, gave a great rundown on this yesterday, but just to recap for those that might have missed it, NFTs have these 6 main properties. That is that they're unique, which I just mentioned. That means it can represent a digital physical product like a collectible, a house contract, a vote, or a ticket. They're provably scarce. NFTs have a traceable origin backed by a cryptographic hash, with supply being controlled by the owner or developer. So this has some great applications for, say, collections, gaming assets, or for limited edition representation of items like, I don't know, signed albums or similar things. It could obviously also be used for things like proof of education. Your degree could be an NFT, or for proof of attendance purposes. So there's applications that are way outside just digital art. They have guaranteed ownership, which is a property inherited from the blockchain, and that ensures traceability and data verifiability. So this gives rise to application usage for things like identity and authenticity purposes. So if you want to authenticate that your bottle of wine, for example, is you know, the original bottle of wine and not a copycat version, or your Prada or whatever you're into, your Nikes, then you could use something like an NFT to prove that. So they're fraud resistant. So because NFTs are secured with cryptographic proofs, they can be used in things like voting or membership rights, for securing identity and authenticity again, for legal applications, for both digital and physical things. And I also know, because I'm ex-IBM, that IBM's currently using them to ensure the authenticity of patents, for example. So as an enterprise or business use case there. So 5th property is that they're transferable. So that might seem a bit weird, but NFTs can also be transferable, so they can have value inherently attached to them. And this gives rise to use cases in asset management or finance records, or also royalties. So if you resell an asset, for example, if you resell a song to someone else, you could still keep getting royalties, or you could have a charity NFT that when it's, transferred to someone else for a value, still continues to pay the charity, for example. So there's applications like that we're currently seeing as well. And the last one is they're indivisible, which I've kind of mentioned before, that they can't be used for things, which means that, it's not Bitcoin or money. So that means they can be used for things like fractional ownership purposes, for example, like in real estate, or I saw one with fractional ownership of yachts the other day, which is kind of interesting. So these are the properties that open up a really unique, excuse the pun, opportunity for use cases and applications to be based on NFTs. And this is where I really want to encourage you to start when you're thinking about new applications and use cases they could apply to, and where they could be used in some really interesting ways. So I've talked to a few of the potential applications of NFTs, but really we're only seeing the tip of the iceberg in terms of what industries they could apply to, or how they could be integrated with other fast-growing technology fields like IoT, or I know a lot of you are into AI and ML here. And there's definitely applications where integrating these kind of things would be really interesting. One of the other great things about NFTs is because they're based on smart contracts, the code can be extended. It's super flexible. You can then apply it to things like insurance, identity verifications, authentications, and you can trigger these contracts in a trustless, automated way on the blockchain. So cool. I could probably go on about this, but I know I promised you that I was going to show you how to actually code it. So let's get into how we'd go about constructing an NFT. So the current Ethereum, or an Ethereum compatible standard for NFTs, is called ERC 721. So you could code up an NFT from scratch rather than use this standard, but a better approach is to use a community vetted and security audited implementation of this standard, and you can find these on OpenZeppelin. So OpenZeppelin has a range of standard implementations and utility contracts and libraries that they used widely by the industry and community to create not just NFTs, but tokens as well. And they have a bunch of utility contracts as well that are really useful. So you can use these contracts on any Ethereum compatible chains. So your layer 2s like Polygon, or compatible chains. I think AVAX is an AVM compatible chain near. You can use them on anything. So this is a good thing about starting with an Ethereum-based contract if you haven't done much smart contract writing before. So the OpenZeppelin ERC 721 standard, which you can kind of see a little snippet of here, and I think I do have it open somewhere as well. So this is the OpenZeppelin docs here. And gives you a little bit of a rundown on how to create them. And here's the API. This is documentation for coders. You can see all of the functionality there. But the main function we want to look at here is the mint and the set token URI functions, though. So if we look at this example contract implementation, we can, which is, I will just click. Hopefully my animation works. Woo, it does. Okay, so this is an example implementation that I've taken straight from the OpenZeppelin documentation. And this, if we have a look at it, it's just showing how to create a game item. So we see this contract creates a numbered ID game item for a player with a wallet address, and it takes a token URI, which is a universal resource identifier, as a parameter. So constructor, ERC 721, the name of the collection, the symbol for the collection. And this function here is where the token gets minted. So address player, the award item, takes the address of the player, so where you're going to, who owns this NFT. And then the string, the token URI. And then, it mints that item, and then it sets the token URI to that NFT. So it's pretty basic code here, and you can make an NFT as simply as that. But this is where it kind of gets interesting, because the token URI is simply a JSON object containing the unique characteristics of the NFT. So for example, here it's Thor's hammer. But what's important is that we really want to ensure that our metadata conforms to the characteristics we're looking for in our NFT. So it's non-fungibility, it's uniqueness. And so where and how we save this metadata is a really important consideration. And there's three main ways to save this NFT metadata. The first one is you can save it in the contract itself, which is probably, you would argue is the best way to do it. But the problem with this is that it can get prohibitively expensive to store information like this, especially on the Ethereum chains and on many chains. So particularly if you've got a large file, for example, images, music, video files, these are really large files, and storing them on especially Ethereum, it's just prohibitively expensive and you don't want to do it. You could also use, like they've done here, a HTTP address to fetch the NFT image. As we can see, they've used it here, but unfortunately there's multiple issues with this. One is that we're relying on someone to continue to pay for this storage, and that the service doesn't go down. And we've all seen Amazon and all the other clouds go down at some point or other. But the second more problematic one is that we're also relying on this HTTP address to always resolve to the same data. If someone wants to change this data and has access to this server, our non-fungibility property would get lost. And that's kind of a big concern when you're trying to make a non-fungible token. So that kind of brings us to the third way. You can save it to IPFS, content ID, and Filecoin. And even actually, Open Zeppelin has some notes on this. So they say at the bottom of this contract implementation, some notes that I just went through, basically, that you probably shouldn't do it the first two ways, and you should probably use IPFS and Filecoin. So I'm not just trying to sell here. It's actually a community standard for doing it. Yeah. So just to backtrack a little bit for those that may have missed what IPFS and Filecoin is as well. So IPFS is a protocol which uses content addressing rather than domain addressing. And that's kind of really interesting when you start going down the rabbit hole and looking at it, and really leads to some cool stuff that you can do with it. But I digress. Basically, instead of having content resolved based on the HTTP like domain name, the content is guaranteed to be the same at the cryptographic hash that we ask for, which is a big benefit for NFTs. So IPFS allows users to store and transfer verifiable content address data in a peer-to-peer network. And it even allows you to persist the data, it allows you to persist the data you want on your own IPFS nodes with pinning. But the data will only exist on the network as long as one user continues to store it, and therefore be able to provide it to others when they request it. So this is where Filecoin comes in. It builds on the unique content addressing of IPFS to add longer-term data persistence with crypto-economic incentives for storage providers. And this ensures files are stored reliably over time, multi-generational, and for multi-generational timeframes if you want, or even just short timeframes. If you only want to save it for a day, you can also do that. Probably not with NFTs, but you get my drift. And it's cheap, and it's stored in multiple places at once because it's a distributed network. So this is why we use IPFS and Filecoin for NFTs, because you need storage that's off-chain. On-chain's too expensive. You need a fixed address for the content to live, which is where IPFS comes in. And you need storage that's persistent and reliable, which is where Filecoin comes in. Now, building directly on IPFS and Filecoin isn't necessarily the easiest thing to do. So what has been built out is a few helper tools that kind of enable us to have a couple of lines of code inside our front end to enable us to do that. And one of the big ones is Nft Storage. So Nft Storage is, primarily storage for NFTs. So to store this kind of metadata, and they're offering it for free at the moment. And all you do is get an API key, you put it into your code, and you can use Nft Storage and then send that to your contracts. But okay, so this is the project that I've kind of created for you guys, a little Faber Web3 hackathon project. Let's take a look at it if I can find it. So here it is here. I think this is just my localhost version. Yep, it is. So basically, you know, just need to connect to a wallet, which I might need to see my toolbar for. So I'll just back up a little bit. So sorry, I always have so many tabs open that I have a suspender on just to save myself some storage on Chrome. Anyway, so this is Nft Storage. These are the docs. It's pretty easy to start with. You just create an account like you do with anything else. And then all of a sudden, you can, you know, store as many things as you like. And I think if I just go to this page, I should be able to see all the files that I've previously saved going through my front end, which are going to take a while to load because I think I've saved so many things. So if we have a look here, you can see that this is the Ipfs hash, and that can represent a bunch of different things. It could just be one image, it could be a whole JSON file, it could be multiple JSON, like multiple images or multiple NFTs in a JSON file that you pull out as you like. It can basically be anything. So that's the flexibility there. All right, let's jump into the code though. So where have I got my code? Sorry guys. All right, here we go. So all I've done here is to create this program is to create a pretty basic backend Solidity contract, or backend Solidity contract, I should say, which is Ethereum language. And you can see I've imported the Open Zeppelin contract to do this. Excuse me. So I'm creating a Filecoin ticket NFT, which I'm going to give you a link to near the end of this talk, so you can go and mint one for yourself on the Ring-Fear network, so you can get free ETH to mint it, and look at it on Rarible or OpenSea, which are two big NFT marketplaces. But basically, I've created a contract which creates this Filecoin ticket NFT. I'm using some helper functions to keep track of the token IDs. So each NFT in this collection, in this contract, will have a specific ID because, like I said, they're all unique. I'm only going to allow 100 NFTs to be minted here. So I am, you know, creating a collection that's only ever going to have 100 NFTs. So that's my max NFTs function there. And I'm just going to store some details about the NFT in this struct here. So for example, the owner, the URI, which will be an IPFS address, and the token ID, just so that I can get that collection back and display it on my front end easily. I've also got a couple of events here. So when we do mint a new NFT, an event will be emitted to the blockchain, which my front end can keep, a track of. So the event can then be pulled in to my React front end with just a basic listener. And I'll always have an updated site that way. So my constructor, the ERC 721, the NFT standard, is going to create this name, and well, this isn't the best symbol, but so Faber Web3 Hack 2022, Filecoin starter NFTs. And I've set my max NFTs there to 100. Then I've got a second function, and this is where all the action happens. So when someone, you know, connects, I will need to connect to my wallet. So, but when someone presses this button here, so enters their name, and I'm just going to write, so I've actually also put a limiter, as you might have seen here, this account already owns a ticket. So I've actually put a limiter in here because I only want one of these NFTs per address. So I've coded that into my contract so that only one NFT can be minted per address. So I'm just going to change accounts, just a sneaky way around it really. and I'll be able to mint another NFT here. So hi, Faber. This is really meant to have a name on it because it's, the idea is that it's a ticket. So you can, personalize this, write your own name, put your ETH address in, something like that. And then when I click this mint NFT button, basically my React front end will hit the contract here, mint my NFT. This is where it checks that I don't already have a NFT. And then it safe mints. So it safe mints to the person that's asking for it with the token ID. And then I'm setting the token URI, which I pass into it because I'm going to dynamically generate the SVG that's displayed on this front end here, on the front end, and pass that into my contract. So that's what I'm doing there. And then, yeah. And then I emit this event that a new NFT has been minted. So that's the basic contract there. If you do have any questions, please feel free to shout out. And I actually can't really see the chat, so apologies for that. But if you do have any questions, please, shout out or feel free to ask at any time or get in touch with me after this. So let's get to the front end where all the magic happens with Nft Storage. So this is a basic a Create React app for, I think most people have probably heard of Create React app. You could do this in JavaScript, any kind of front end you like, basically. But this is where the magic happens because I'm using Nft Storage from Nft Storage. And like I said, all I had to do was create an account and get an API key. So I've created an API key for this React app Nft Storage key. I won't show you mine because, security and all that. But as an example, this is what I'm using, just an API key in my front end app. Excuse me. All right, where's my function? All right. So when I do click on, create NFT, basically, it is going to be this create NFT functionality. And also I'll give out the GitHub link for this so you can go through this at your own leisure and have a look how I've done it and maybe fix up some of the mess. I did this in a bit of a hurry, but basically I can show you what the create NFT data does. So I connect to Nft Storage. So I'm creating an Nft Storage client with my API key. And I'm then going to create the data for my image, which I'll put in JSON. And I do that by, I've got a base SVG here. It's super long, but because I didn't, it's quite a complicated image and I just created it with an online version. There's probably ways to optimize this, but I've basically got this base SVG. And at the end of that, I'm appending the person's name that they input. So this name is our input tag, and then finishing the SVG with that. And I'm just using this crypto.js encrypt library just to make sure someone doesn't try to create a different image to send to our contract instead, because I kind of want to ensure that. But those are front end security issues. So then all I have to do is go client.store and I pass in the JSON that I want, which is the name, description, the image, and maybe any traits or anything else you want to add to this NFT. For example, I've gone traits awesomeness 100 here, but you could add any trait you wanted into your JSON, or you could also just pass the image that you wanted into your contract and do the traits on the actual contract itself, because they're probably not as storage consuming, so it wouldn't be as expensive to do that. So that's another possibility here. But then I just, so this will go through to Nft Storage, be stored automatically and give us back an IPFS cryptographic hash, which I think we should be able to see in my thing here. So this is where it says metadata saved, and this is Nft Storage returning with an object. And as you can see, this is the IPFS URL that it's saved as. So it's just saved as IPFS cryptographic hash / metadata.json. and further data, description, image, name, all those things that we just sent in. So really cool, really easy. And I'll just get rid of this remix. I was going to show you how to test your contract, but probably don't need that. And that's really all it is. That's all you have to do to save your data to the front end. And I'll just approve this transaction. So because I haven't approved it, it's still loading. So the image has been created on Nft.Storage, but I haven't confirmed this to be an NFT yet. So I haven't sent this transaction to the blockchain. So I'm just going to confirm that to actually mint my NFT. And pending transaction. Awesome. So we've minted it. So now we can see that transaction on Etherscan. I'll just get rid of that one. So Ringp testnet transaction. So make sure if you do go to this site later that you are on the Ringp testnet, not spending real F on this. You can then go and see your NFT on Rarible. So Rarible or OpenSea, excuse me. It does take a while to propagate through to these, so it might not be immediately available. But OpenSea and Rarible, and by the way, OpenSea does use IPFS and Filecoin for their minting. They've got a, mint an NFT, you just drag and drop, and you can basically create a collection in OpenSea itself. And they do use IPFS and Filecoin for their metadata as well, which is kind of fun fact there. But yeah, you will be able to see this token. It just takes a while for it to propagate through to these platforms. And that's basically it for saving to Nft Storage. The only other thing that I maybe want to talk about here is, this is my ask contract to mint NFT. So this was my create the NFT metadata and send through nft.storage. And then this is me asking the contract to mint that NFT. So sending it to my contract function just here. And you can have a look through that if you don't know already. And this is where I set all that contract address and the Rarible, where to go, the links basically, the Rarible link, the OpenSea link, the Etherscan link. So I set them here. So the other thing that you might be interested in knowing about is how am I getting these images to display in my front end. So, if we have a look again at this token metadata and say I go to this, let's get this URL. So it says IPFS / cryptographic hash meta.json.data. If I open that up in Chrome browser, did that work? Whoops. It won't actually work. And that's because Chrome browser doesn't by default have IPFS installed on it. So we need kind of a HTTP gateway. If you're using something like Brave browser, or I think Opera as well, they natively have IPFS links installed in them. So if you're in Brave browser, you can go straight to that link. And this is actually Brave browser, so I might just put it in here. And Brave will use a IPFS HTTP gateway to return the data for us, which is cool, but we want to be able to use it on any browser we go to, right? So in order to do that on my front end, what I'm doing is creating an image URL for creating an IPFS gateway link in order to display it. So I will retrieve the data from the backend, from the function where I was storing all of those in an array basically. So every time one was minted, I put it in an array, and I had a fetch function where I could see that data. So every time we reload this page, it will get this NFT collection, of which there is currently 2. And it fetches this back. And then I need to convert this IPFS link into something that's readable on any browser. So I do that by using a HTTP gateway, basically. And you can have a look at, there's a web page where you can have a look at the status of HTTP or IPFS, HTTP bridge links. So you can have a look at all the people that are using them. But this is usually the recommended one, and it's HTTPS, the link, so the cryptographic hash, ipfs.dweb.link. And that's how I'm basically fetching it on the front end. It's really kind of as simple as that. There's my fetch NFT function as well. Yeah, I think that's about it for creating the NFT contract and creating this whole thing. As I mentioned, I've got a GitHub and happy for you to use that. But otherwise, feel free to play around with this to yourself. I'm just going to post the link into the Zoom chat now. So this is currently hosted, and how I'm hosted it, and it's on a different contract, so there's actually none that's been minted yet, but I've posted that into the chat, so feel free to jump on there and mint yourself your own Faber Web3 NFT. But I am using Fleek in order to host this. So Fleek is a really cool Netlify / Vercel like deployer, so hosting provider. But what's unique about it is that it is using IPFS, or you can choose to use IPFS under the hood to host things. So this gives you some guarantees, and it's like kind of my favorite thing. And I've just hosted, it's super simple, like it's as simple as connecting to the GitHub that branch that you want to host off. If you make a change on the GitHub branch, it will automatically redeploy. But yeah, basically all you have to do is connect to this to your GitHub account where your code's hosted, and then yeah, add your environment variables if you like. So some of your advanced build settings there, which I've just shown the world, but all good. And it will continuously deploy. You can obviously, also then attach a domain name that you want to it, or you can just use their generic one, which in this case is Snowy Sun. Kind of cool. So I really recommend checking out Flake if you want to really have your front end dApps be hosted in a decentralized and reliable manner as well. I think that is just about all I had for you guys on the live code. As I mentioned, please feel free to ask any questions you might have of me here. Just already went through that one, so probably don't need it. So yeah, mint your own Faber Web3. I've shown you the link there. You can get Ringpy ETH on faucets.chain.link/Ringpy as well if you do need some fake ETH to mint one. Thank you again. It meant a lot. I like that. Nice pun. And there's the GitHub link as well if you do want to use this as the basis of some of your projects. But thanks all, and hopefully that will help some of you now or in future when you watch this asynchronously to get started with your potential NFT projects. I think that's about it for me, Carlos. I might be a little early on the timing there even.
No, that was great, Ali. Thank you very much. That was fantastic. I'm certainly going to run and try to get one of those 100 NFTs. I want one for the Faber Web3 Hackathon, so I'll certainly do that. That was very cool. I'm also looking forward to kind of start minting my own NFTs. That was a very good insight of how to do it. Let me just see if there are any questions from the attendees.
Definitely. So I know it was a little bit quick, and maybe if you don't have an understanding of Solidity or how to develop on Solidity, so in those, you can have a look at my GitHub notes as well. It might give you a better idea of some of the tools that I've used to create these contracts and put it all together and deploy it as well. So I'm using a service to deploy these contracts and things like that.
And is Fleek kind of a distributed version of Netlify, for instance? It seems very similar, doesn't it?
Yeah. It's exactly. It's so similar, except for that it uses IPFS hashes for your content. So you can kind of always go back to that hash, pretty much like GitHub does. you commit something and you get, each commit kind of hash. It's a little bit like that. So that's kind of cool. But definitely, if you are going to create, decentralized products, then you really want to be hosting it in a decentralized manner as well. And that's where kind of Fleek steps in, which is awesome.
Yeah, it looks really cool. I'll give it a try. I've been using Netlify for some time, but I'm going to give it a try to Fleek as well. So thank you very much. That was a really cool session. So we're going to have this. So we're recording this, and we're going to have this published sometime next week, so people can go over with more detail. And I'm sure they're going to kind of be looking at it step by step. Ali, thank you very much. It was a pleasure to have you. We're now going for a break, a 15-minute break, and we're going to come back at 15 to noon in this case, but depending on your time zone, that may be slightly different. So 15 to, we'll be back, 15 minutes break. Thank you very much. Thank you, Ali.
Thanks, Carlos. Thanks, everyone. And happy hacking. Looking forward to seeing what you come up with.
Thank you.